Welcome to lesson number 7, example number 5. It is asking, what is the allowable load per lineal inch on a 1/4 inch fillet weld made with E70 electrodes if the connected parts are ASTM A36 steel? And if you remember, what you want to look for is figure out what this distance is. Let me change colors. Is the throat. I hope that makes sense. You should know from 45-degree triangle. If you have a 45, 90-degree triangle, and you use Pythagorean theorem, this is H. Well, let's use ABC. A, B, C. And you know A squared plus B squared equals C squared. A and C squared. A and B are the same, so it's going to be, I won't even go through the math. C is always going to equal, we're looking actually for this dimension, aren't we? Actually, I'm going to change these A squared, B squared, C squared into something different. Because I was looking at the wrong, I was thinking that hypotenuse. We actually want to look for this hypotenuse right here. So let me go ahead and change like purple, let's say. So this is our new 90 degree, and this is 45 over here. If we drew a 90 degree line right here from a perpendicular line. Alright, so now we have 45, 45, 90. And let's say, since we're saying this is 1, the weld size is right here. That's our 1, but that's now our hypotenuse. So we're looking for these. That's actually going to be C, and this is going to be A and B. And A and B are the same. So this is going to be C. Our C is going to be this one. I hope that makes sense what I'm trying to do here. So I guess this length plus that length divided by C squared. We know C squared is going to equal 1. So we have to say, what was that, 2? Let's just call it 2a squared. Then we have to divide, so it's going to be, I'll just go ahead and do my math, sorry. It's going to be 1/2 equals a squared, and then we have to do the square root of each side. Square root, and a equals the square root of 1/2. And that should equal 0.707 whatnot. Let's do our calculator real quick. Get out our calculator. 0.5 to the 0.5. Yes, and it is. Square root of 1/2 equals 0.707, blah, blah, blah. But that's why you use that 707. That's where that comes from. This distance is 0.707. And this is using a unit triangle, I would call it. And unit usually means you just have sides equal 1. So, alright, so any side you have, this is your side, this is your weld size, you're just going to multiply it by 0.707 and you're going to get pretty much the minimum thickness of anywhere from this triangle. From here to there is always going to be longer, here to here is of course going to be longer. This is the least amount of thickness. Alright, I did enough to explain that. I hope that makes sense. If not, go ahead and write some questions and I will attempt to explain it as needed. Alright, let's go ahead and get started on this example then. Alright, and this dimension right here, that's assumed to be the area. I don't know if I made that clear. 0.707 times the weld size is the area. It's the assumed area. So we get, what, 0.707 times 0.25 is 0.177 inches squared. And then we want to look at what is our allowable. And our allowable is using A36 and E70. If you go on page 132, you see that 21 KSI for welds made with E70. So our allowable shear stress equals 21 KSI. So we want to multiply this by that. 177 inches times 21 KSI equals 1.177 times 21, 3.7, let's say. And as you can see, if you take kips times kips per square inch, you get kips. So that's 3.7 kips. And that is going to be per inch of weld. And that is your answer. 3.7 kips per inch of weld.